Before we talk about IP addresses, before routing, before the internet, there's one basic question that we have to answer first. How does the switch know where to send data? Because inside a local network, data isn't teleporting. It has to leave through a specific physical port. And that is the core problem. Devices inside the same local area network still need the network to answer which path, which port, and which cable. And this is why Ethernet switching exists. Let's make the situation very specific. Your laptop is on the same local network as your printer, or your PC, or gaming console. In that scenario, there is no router decision happening yet, because routers are for moving traffic between networks, but right now we're staying inside one network. So the network isn't asking which country, which ISP, which internet path. It's asking something way more physical. Which cable do I use to reach that device? That's why switching feels simple, but it's actually the foundation that makes everything else possible. Now we need to understand what information a switch actually has available. A switch is a layer 2 device. That means it makes decisions using Ethernet information, not Internet information. So when a switch receives traffic, it does not look at websites, apps, usernames, or IP routing. All of that is either higher layer stuff or it's inside the payload. What the switch does look at is exactly what you see right here. Every Ethernet frame contains a source MAC address, who sent it, a destination MAC address, who should receive it, and a payload, which might contain an IP packet, but the switch treats it as a sealed envelope. So the switch is basically saying, I don't care what's inside, I only care who it's from and who it's for. And this is the key line. This is the only information a switch uses to make decisions. Now we reach the first major behavior, learning. Here's the mental shift most beginners need. The switch doesn't start with knowledge. It doesn't boot up already knowing where devices are. At the beginning, the MAC address table is basically empty, so the switch begins life ignorant. So how does it become so smart? It learns in the simplest way possible, by watching the source of frames that enters it. And this is important. Before the switch even looks at the destination, it learns the source. Why? Because the source MAC is proof of location. A switch can safely assume that if a frame came in on port 1, then the device with this source MAC address is reachable through port 1. So the switch writes a note in its memory, MAC address of PCA to port 1. This is exactly why we say switches are reactive. They don't scan, they don't ask for introductions, they don't announce themselves. They sit quietly and learn only when traffic happens. Now let's look at what happens when the switch does have the information it needs. A frame arrives and the switch does two mental steps. Step 1, I learn the source. Step 2, now I check the destination. So the switch looks at the destination MAC and asks, do I already have the table entry for this MAC address? If yes, everything is easy. The switch says, I know exactly which port leads to that device. So it sends the frame out to the one correct port. No guessing, no broadcasting, no noise. This is called forwarding. This is why switching is so powerful. Forwarding is efficient. It only one port gets the frame. It's quiet. The rest of the network doesn't see it. It's more secure because unrelated devices aren't receiving the same traffic. A good switch spends most of its life doing this. The switches don't always get the perfect situation. What if the destination MAC is not in the table? This is where people panic and think something is broken. But it's not broken, it's expected. The switch is in a situation where it must deliver the frame, but it doesn't know where the destination lives. So it chooses the only method that guarantees delivery. It copies the frame out of every port except the one it came in on. This is called flooding. And I want to be very clear on the meaning here. Flooding is not a random thing, it's not a mistake, and the switch is not being dumb because of it. Flooding is a deliberate fallback strategy that says, I don't know who has this destination MAC address, so I'll ask the whole network by sending it everywhere. And the reason it excludes the incoming port is simple. Sending it back where it came from would just be pointless. Here's why flooding doesn't destroy the network forever. Because flooding creates the opportunity for the switch to learn. If PCB receives that flooded frame, PCB will usually reply. And that reply is crucial because now PCB becomes a source. So when the reply enters the switch does what it always does. Before anything else, it learns the source MAC address. So now it writes MAC address of PCB to port 8. And this is the key cause and effect moment. The switch learns only because the destination spoke. No configuration, no announcement, no hello, I am PCB, just traffic. Now the switch knows both devices. So the next time PCA sends traffic to PCB, the switch checks the destination MAC address, and now it is in the table. So flooding stops. From this point forward, traffic becomes a unicast. One sender, one receiver, one correct port. This is the big story of Ethernet switching. At first, there is uncertainty, flooding happens briefly, a reply teaches the switch, then everything becomes efficient automatically. Now let's walk through the full sequence slowly, using exactly what we've seen. First, PCA sends a frame to PCB. When that frame enters the switch learns PCA's MAC address and the incoming port. Then it checks the destination PCB. If PCB is not in the table, the switch floods the frame to all ports except the incoming port. PCB receives it and replies. When the reply enters the switch learns PCB's MAC address and the port it came from. Now the table contains both devices. So future frames are forwarded directly to the correct port, and flooding is no longer needed for that destination. Nothing magical, just consistent rules. One more important detail, without changing what you already understand. MAC table entries don't last forever. Switches uses timers, so if a device stops sending traffic for a while, the entry can age out. This is not a bug. Because networks change, devices unplug, people move cables, ports change. So the switch forgets all the information so it can stay accurate. Thank you.